All right, folks. We've got a new unit here. Unit 4. We're moving on. We're out of solving for a little while. No systems to solve, no equations to solve, no graphing to do. I bet you're happy. Let's look at what we're getting into today. It's exponents and radicals in this unit, and let's take a look. All right. Do you guys remember exponents? It's probably been a while, hopefully not too long. Hopefully you remember these. So if we see this idea of 4 to the third, and that's how we'd say that, 4 to the third power. And if we are to expand that and write it out, and this is what it means, expand. To expand is to write one of these exponents out in its full form. And what it's telling us when we see 4 to the third power is this. Okay, it's 4 times 4 times 4. That's what an exponent means when you see this. So in terms of vocab, let's see what we're talking about here. This number is your base. 3 is the base on this problem. And notice these are two different problems, the original one I just wrote and this vocab one on the right. This 3 is your base. This upper number, the 4, is the exponent on this problem. So if I'm going to write out this one, I'm going to expand it just like I did the original problem. I'm only writing the base. Notice that. Okay, I'm writing out the base repeatedly, and how many of the base is where the exponent comes in. Okay, that's what the exponent tells us. It tells us I'm multiplying a bunch of the base number together. And how many am I multiplying? I'm multiplying that many of them together. Back up here to the original. The base was 4, so I'm multiplying 4s together. And how many of those 4s am I multiplying? I'm multiplying 3 of them. Okay? That's what the problem tells us. The important thing to notice is there is no exponent in the actual calculation. Notice there's no 3's anywhere in that problem. It's just 4's, just the base is multiplying. If you look over at this side problem with the vocab, the base on that problem is a 3. That's all that we're multiplying. There is no exponent, no 4 anywhere in that problem. Okay, so what I repeatedly will see is something, I don't know if my screen will slide, there we go, something along the lines of this. If we write 2 to the 5th, the correct way to do this is to expand and say there are 2's being multiplied, and how many of them is 5. Okay, that's what, whoops, one more. That's what we're saying. So that answer, 2 to the 5th, actually equals 2 times 2 is 4, times 2 is 8, times another 2 is 16, times another 2 is 32, okay? So, 2 to the 5th, correctly done, is 32. Incorrectly done, what do you guys think people do when they're first learning this? Kids end up jumping to this. See it all the time. They think multiplication. That's incorrect, okay? This is 2 times 5. When the 2 is a base, and the 5 is a base, it's just 2 times 5 makes 10. When we're dealing with exponents, we're just multiplying a whole bunch of 2's together, and that's how many 2's are multiplying. So it is a multiplication problem, but it's a repeated multiplication of the base number. It's a whole bunch of 2's being multiplied. How many 2's is your exponent, okay? All right. So 4 to the third to finish the original problem. That's 4 times 4 is 16 times another 4 is 64. Okay, that's what 4 to the third equals. That's how you calculate that out. If we were going to do this vocab problem, it's amazing how the screen app doesn't work half the time. If we're going to do this vocab problem, 3 to the 4th is 3 times 3 times 3 times 3. You can also group them together and say the first 3 times 3 is 9, second 3 times 3 is another 9, and 9 times 9 is 81. So 3 to the 4th makes 81, not 12. It's not a 3 times a 4. It's a whole bunch of 3's multiplied with each other, and the exponent tells us how many 3's to multiply. Okay? So that's a basic review of exponents. Now, what's this whole question of the invisible 1 over here? Well, if I write the number 5, and we don't see an exponent here, there is an exponent. Do you know what it is? I bet you do, because we're talking about the invisible 1. It's a 1. Every number, every variable always has an attached exponent. If there's nothing there, the exponent is 1. So if I wrote 27x, I'm actually saying 27 to the first power, x to the first power, and it's just invisible because every number always has the 1 there. So anytime you're learning exponent rules and working with them, remember there's an invisible 1 on every single value. Every constant, every coefficient, every variable, every term, they have an exponent, and it's 1. All right, let's start applying some rules and playing around with exponents now that we kind of have the idea. Here's our first set of exponent rules. X to the 4th, we just talked about it. We know that that now means x, 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 x. To expand it out, that's expanded form, remember. That's a really important word when we're dealing with this exponent unit. I'll be asking you to do that a lot in homework or in the practice problems when we do our live sessions. That's expanded out, and it's just 4 x's multiplied together. Again, there's no 4 in the problem, only x's. X to the 3rd, pretty simple. Expand it out, there we go. So if that's the case, therefore, if those are what those equal, what do you think x to the 4th times x to the 3 would equal? X to the 4th power times x to the 3rd. Well, turns out if exponents are multiplication, and I'm already multiplying 4 x's, and x to the 3rd is just multiplying 3 more x's, and parentheses mean to multiply, then I think this problem is just saying, if I rewrite this first one in green, x to the 4th is saying that times the x to the 3rd is saying that. Let's move this guy over. Oh no, of course. Stupid thing. We'll get to that in a minute. Notice if we write those out, what are we saying here? This is just an expanded form of an x to the 4th times an x to the 3rd. They're all multiplying. How many total x's are there? 1, 2, 3, 4, 5, 6, 7 of them. So I guess that means we could just rewrite it as x to the 7th. Okay? Again, this one is just saying 4x is multiplying. This one is 3 more x's multiplying. If I put them next to each other with a parenthesis, I'm just saying multiply 4 with 3 more, which is a total of 7 x's multiplying, and there's rule 1. That's our addition rule. Okay, now notice, I'm going to point this out and be really explicit. The addition rule of exponents is saying if you multiply, I'll say multiplying bases mean you add their exponents. Okay, because I was multiplying down here with those groups of x's, because an exponent by its nature is multiplication. If I'm multiplying 2 groups of exponents, bases, the whole thing's, the bases are being multiplied, I'm just accumulating two groups of multiplication, so I'm just going to add them all up, and I've got 7x's. Really simple. So one other thing, I said multiplying bases, so if we look here at this yellow problem on the side, would that mean that we put together all of those and make a 7? Okay, the answer is no, and that's because that's 4 x's, that's 3 y's. All of the exponent rules only apply if they're a common base, or if they're the same base, okay? If they're not common, then none of this would work. Quick little side problem to show you. If I did 3 squared and 4 squared, well, 3 squared is 3 times 3, that's 9. I was going to multiply these guys. And 4 squared is 16, that's 4 times 4. What's 9 times 16? That's 144. If I tried to combine these guys together and say 2 and 2 makes 4, 4 of what? Would it be 3 raised to the 4th power, 4 raised to the 4th power, 12 raised to the 4th power? What would we do? And no matter what we pick, if we want to put a 12 as the base, it really doesn't matter. Nothing is going to work. If I tried to multiply and make it 12 to the 4th power, that doesn't equal 144. That equals a number way bigger than 144. 112 times 112 equals 144. If you keep multiplying the 12s, we're going to be up in the many thousands. So it shows us that if you don't have a common base, none of these rules are going to work. You can't do anything with a 3 squared and a 4 squared. They have to be 3 squared with other 3's to an exponent. Something that's the same base. Without it, none of these rules work. You've just got to be able to calculate out the exponents individually. So all of this unit, all of the stuff we're looking at, is basically how to play around with, shrink, expand, simplify. But you've got to have that common base. It's got to be x's with x's, y's with y's, z's with z's, 5's with 5's, whatever number or variable you're working with, make sure it's common. You know I'm going to throw these at you, like this one here we were just looking at. So if you're asked to simplify that, you leave it as is. There's nothing you can do. X to the 4th, y to the 3rd remains x to the 4th, y to the 3rd. And notice if it's two variables, you don't even need these parentheses anymore, because we know they're multiplying if they're written together. You can take them off. We still know that's a multiplication going on. We can't do anything because they're not common bases. All right, why don't you take a minute and try those 3. Pause it, should take you like 30 seconds, and we'll move on. All right, let's dive in and see how you're doing. First check, common bases. So I've got 5 x's multiplying together with 4 more x's, which is a total of 9 x's that I'm multiplying together. So it's just x to the 9th. Literally that simple, guys. Notice how simple it is. Here, I've got common bases again, so I'm able to use my rule. 3 and 4 means 7 total y's. Oh, and I have another one. What's there? If we don't see anything, hopefully you guys remembered it's the invisible 1, which means we have a total of 8 y's all being multiplied together. Literally just add them, it's y to the 8th. Last one, I tried to throw a curveball at you. That y is not common, but the other 2 are. So I could put those together. That's going to be an x to the 9th. Just add the 5 and the 4. And I've got to leave the y separate because he can't combine. He just sits on the end. All right, let's move on. If they're multiplying, you're just adding together the 4 plus 3 to make 7. Back them. So what do I call that? The addition. Okay, next rule. This is basically the same rule as the last page, but in reverse. Let's look. Y to the 5th, if we expand that out, hopefully this is starting to become pretty easy and pretty rote for you guys. There's just 5 y's. Y to the 4th, I'm going to expand that out as 4 y's. So, therefore, what would it be if I did division with these two, y to the 5th divided by y to the 4th, well, it's really easy to just expand out the top, expand out the bottom, and then it's as simple as applying our division principle. If I put a side problem over here, what would you guys say is 3 over 3? What does that equal? Okay, well, we can ask ourselves, since a fraction bar means divide, you're dividing bottom into top. How many times will 3 go into 3? It'll go in 1 time. Another way to ask that is anything over itself equals what? Equals 1. So however you want to look at it, if you've got something over itself in a fraction, it's just going to become 1. So if we go back to this problem over here, that equals 1, that equals 1, that equals 1, and that equals 1. So what we end up with is basically 1 times 1 times 1 times 1 times y. Well, what's anything times y? Wait, I said that wrong. What's anything times 1? It's just that number, okay, or that variable in this case. 1 times y is just y. So if we're going to go back to this problem, we really can simplify and say this. Anything over itself cancels out. And this is what we've been doing for weeks with our equation solving now. If I have 4x equals 8 and tell you to solve for x, we do this. We cancel out those 4's and see that x equals 2. We do that canceling because 4 over 4 is just 1. 1 times x is just x. So the shortcut is anything divided by itself cancels out. And we do the same thing on this problem with all the y's, which means our answer is just y. What's a really easy way to simplify that? If you have 5y's over 4y's, and the answer equals y, which is, remember, 1, the invisible exponent, I bet you see it. It's just subtraction. It's just 5 minus 4. And that's it. Notice the last. If they're dividing, that's just the opposite operation. So it's a subtraction. 5 minus 4 equals 1. So common bases multiply, you're going to add them. Common bases divide, you're going to subtraction. Subtotal. So let's call this subtraction rule. You have a common base, remember that's always required. You have common bases that are dividing. You can just subtract those exponents. All right, so hopefully that's seeming pretty simple. Why don't you pause it, do those 3 practice problems, and I'll be back with you in a minute. Go. All right, if you're back, let's dive in and see. There's 3 practice problems, and right here we've got the common base p. 11 p's over 4 p's means we're going to just subtract 11 minus 4 equals 7. If we really wanted to see that, 11 p's being divided by 4 p's, and it's literally just saying cancel, 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 and what's left over on the top? 1, 2, 3, 4, 5, 6, 7. P to the 7th. There you go. Those are all multiplying p's, so therefore it's p to the 7th. And we'll keep going. M to the 14th divided by m to the 8th. I'm just rewriting it in a different form, okay? These are the exact same thing. Hopefully you guys tracked with that. It's division written in a different form, so it's still, because of a common base, just a subtraction. 14 minus 8 is 6. So 8 of those m's canceled out because they were dividing and they were common pairs of m's. So 8 pairs cancel out, 6 are left over. Last one, did I catch you or did you notice they're not common bases? they're not common, nothing you can do. That's it. It's done. It's as simple as it's going to get. You have to leave s to the 8th over p to the 5th. All right, that's the first. One more. We're only teaching 3 of the rules today. So here's the third one, and then I'll stop. No worries. X squared to the 3rd. Let's see what that means. X squared. And you know what? I'm going to change the color. I think it'll help you a little bit. Let's make that green. All right, interrupted, but now I'm back. So x squared, there's our x squared. And then that raised to the 3rd is telling us that this x squared we do 3 times. So there's the second one, there's the third one. So that's the expanded part of the exponent raised to an exponent. So this third rule, we don't call it exponent, we call it power. Another name for exponents, guys, is power raised to a power. So this rule is called power to a power. Okay, that's what this third rule is called. You don't need to remember the names, it's just giving you something to kind of call them. So now we've got x squared and y. Boy, guys, sorry, that's not supposed to be a 3. Did that confuse the heck out of you? That's supposed to be another 2. We have 3 groups of the x squared, and so now what does that equal if we put it all together? Well, there's 2 x's. There's 2 x's. There's 2 x's, so all together we just have 6 x's. So notice this new rule, power to a power, you do multiply your exponents, which is a tendency for some kids when learning the rules when they're new to want to do in some of the wrong places. But here, this is a correct way to do it. Okay? We have 2 x's, and then we're saying take 3 groups of the 2 x's, and we end up with a total of 6 of them. So power to a power, you actually do multiply the exponents. Now, kids will often get a little tripped up when they're first learning this, and let's look at where. This versus this, okay? Power to a power, and this is just our addition rule, which we learned like 5 minutes ago, okay? Notice the difference. There's 2 bases here, x's and x's. So this bottom one is saying x and x, and then an x to the 3rd, and that's it. There's 2 x's, there's 3 more x's all multiplying for a total of 5 x's. So if you have 2 bases, you're only adding together their exponents, that's it. But if you go back up to the top, notice only 1 x is involved here. So this 3 is raising a power to a power. That exponent isn't attached to another x. It's increasing the value of the original x squared, okay? So if it's power to a power, that's when you multiply. If there's 2 bases here, that's where you're going to add them. And you're just going to have to learn to practice that difference. We'll have a lot of practice problems. We'll see this in class regularly. It'll be very easy once you practice it a few times. All right, why don't you try those few along the bottom, and I'll come behind you and practice, show you how to do them in a minute. Go ahead. All right, let's look. Right here, we've only got 1 base, p. So we're taking 4 groups of p, and we're tripling it. We're doing 3 times that group of 4, which is going to mean a total of 12 p's. Okay. If we wanted to expand it out, we're saying 1 group of 4, and then raised to the 3rd power means 2 more groups of 4, which is a total of 12 p's. Second problem, this is your addition rule, because I've got 3 m's and 4 more m's, It's only 7 m's. If I was going to write that out, okay, that's the first one. And that's the second one. 3 m's multiplying, 4 m's multiplying. Together, it's a total of 7 m's multiplying. All right, last one. Still trying to catch you with those bases that aren't the same. Did I catch you on that? And there's nothing we can do there. M to the 4, N to the 3rd is as far as we can go because they're not common bases. There's no way to combine them together. All right. I know what you're going to do. Okay? When kids are learning this, there are some typical mistakes they make. I'm just going to point them out right now so you can watch and not make those. Okay? Right here, they might try to multiply. Okay? That's not going to be x to the 6th. There's no multiplication going on. Just adding. So that's x to the 5th. Okay, you're not going to multiply there. You're just putting together those common groups of x's. Second one right here, you might want to add those together. This is when you do multiply. We're saying 5 groups of the 4. Okay, that's what a power to a power means. 5 groups of 4. So we're really just saying this. Okay, 5 groups of 4 makes 20. So think of this as a multiply, not other operations. I don't want to say the other ones. Make sure you see the difference between this and this. And lastly, I will often see kids want to work this out correctly, but they don't see anything. So they don't do any of the actual math. Remember what's there. There's a 1 there, which means z to the 6th over z does have something you can subtract, the invisible 1, making z to the 5th. Don't forget that, okay? Similarly, if I wrote something like that, that's actually x to the 3rd because there's a whole bunch of invisible 1s there between all those x's that are multiplying. So even if you don't see it, remember there's always an invisible 1 that's part of every exponent problem. So add or subtract or multiply accordingly as if the 1 was written. All right, did you know tennis players at the Wimbledon tournament are not allowed to swear? So if you're a sideline judge, they have to learn the swear words in all the languages of all the competitors because you get penalized if you swear. Frankly, that makes me more of a fan of tennis. I kind of like that. All right. So all of this comes together along with normal adding or multiplying or dividing with actual numbers, with coefficients. And you just kind of mix it all up and it becomes fun. They're kind of like logic puzzles. So let me work a few of these out and then I'll give you your homework to do the same thing. Okay, first one. 8 times 4 is just as straightforward as it looks. You can multiply. 32. Then I've got my x to the 5th and x to the 3rd. That makes x to the 8th. Simple as that. Next one. I'll work on this piece first. 24 divided by 8 is 3. Single negative, because you've got your integers going on there, goes to the answer. And now I'll work out my y's. That's just a subtraction. 5y's divided by those 2. 2 of them are going to cancel, leaving the remaining 3y's. Okay, third one. I bet you're getting the idea. We can do some division there. That's negative 3. Single negative goes to the answer. Now I can work on my x's. Don't forget, there's an invisible 1 right there. So it's x to the 3rd over x, or minus x, that 1 on the x. So that's x squared. And then my p's, same exact thing. P to the 4 over p, p to the 3rd, because one of those p's cancels off or subtracts, however you want to look at it. Okay, last one. 28 divided by 7. Well, that's 4. Now I've got some compound stuff going on. I would work on this first. The power to a power makes an x to the 12 on top. And now I can do the division piece afterward. So 12x's over 2x's. Subtract them, which makes x to the 10th. All right? So once you start learning these rules, they all just kind of come together. Have some fun. It's like a logic problem. Okay. Here's your set of 8 homework problems, putting together all of those exponent rules you learned today. I will go behind you and I will do the solutions for all 8 in the video. Pause it now, do the work, and I'll write them up afterwards. Go. All right, let's see. Okay, I've got some common base p. 8 and 4 are going to add together, so that's p to the 12. There's 2 bases, so they just add their exponents. That guy's not common, so just leave him tacked on the end. Number 2, 12 divided by 6, that's 2. And now I've got t to the 8 over t to the 4. 4 of the t's will cancel. 4 will be left out of that top group, therefore. So the subtraction, 8 minus 4 is 4. Number 3, I've got x to the 4th times, or raised to x to the 5th. That's 20 x's. So we end up with 20 x's. And then that one more x makes x to the 21st. There you go. Okay, number 4, 2 negatives will cancel. 24 over 6 is 4. Power to a power makes a w to the 12. I just wrote this one on the last page. 12, w to the 12 over w to the 2 is w to the 10th. Subtract off those 2 to cancel. All right, next one. 8 times 9 is 72. I've got 2 x's there and 1 more there for a total of 3 x's. And then last I've got this y, that's power to a power. 2 times 3 is 6. Y to the 6. All right, next one. Now this one might be a little bit of a curveball. I didn't cover this in today's lesson, but since there are parentheses, this is actually kind of a preview of tomorrow's lesson. This 2 applies to each piece of that whole term. So that's actually saying 4 squared and x squared raised to the squared. So 4 times 4, 4 squared is 16. The x squared is x to the 4th, because that's power to a power. And then we can finish it with the 3x to the 5th. So 16 times 3, 48. X to the 4 and x to the 5 make x to the 9, and there you go. All right, number 7. Remember all those invisible ones. That's really just x to the 4th over x to the 3rd, which is just x to the 1, or remember x, or the 1 exponent is just left invisible, so it's really just x. Another way you could think of it is with that 3 here. It's going to cancel 1, 2, 3, the x's to cancel the 3 on bottom. And there's what's left over. Same thing. All right, number 8. The best teacher you've ever had. Remember, if you want to pass my class, you know what the right answer is. All right, guys. See ya.